Hello guys, welcome back to the Maths Club. This is Paul. I hope your mathematics instructor. In my previous video, which I posted on all my social media platforms, I showed how we could use the knowledge of differential calculus to obtain the equation of the tangent to a curve at a particular point. Today, we are also going to apply the knowledge of differential calculus, but this time around, we will be obtaining the equation of the normal to a curve at a particular point. The normal is a line that is perpendicular to a curve at a particular point. So therefore, the normal is perpendicular to the tangent at a given point. So for us to understand how to obtain the equation of the normal, I will be using the Harvard University entrance examination on how to obtain the equation of the normal, and that equation is given on the board. So join me, ladies and gentlemen, as we understand together how to solve the equation or how to find the equation of the normal to a curve at a particular point. So if you see on the board, it is given that the curve x cubed plus y cubed equal to 6xy. So the curve is given as x cubed plus y cubed equal to 6xy. Find the equation of the normal line. Find the equation of the normal line at the point 3, 3. So the first thing is that you should bear in mind that the gradient of the tangent multiplied by the gradient of the normal should be equal to -1. And you should also bear in mind that the equation of the normal will be obtained from the standard equation of a line. So for us to approach that equation without stress, we note that the gradient of the tangent times the gradient of the normal should equal to -1. You should also note that y minus y1 should be equal to the gradient of the normal into x minus x1. So this is the relationship between the gradient of the tangent and the gradient of the normal. So which means whenever you are asked to find the gradient of the normal, you should first of all obtain the gradient of the tangent. Then you make the normal a subject of formula in this relationship. And for us to find the equation of the normal, since the normal is a line, we are going to use the standard equation of a line in this format, which you can write as y minus y equal to mn into x minus x1. So the question is, how do we obtain the gradient of the tangent? We can obtain it by differentiating this curve. So the curve is given as x cubed plus y cubed equal to 6xy. So we are going to differentiate implicitly. We differentiate implicitly. So the differential of x cubed is 3x squared. You know that in differentiation, the power is multiplying in front and you are subtracting 1 from the power. So that's why 3x squared. Plus, this function is y. So since we are differentiating with respect to x, it means the x has to be under. So the differential of y cubed will be 3y squared dy on dx. Because this is y, this is not x. You are differentiating with respect to x. This one does not contain dx because they cancel out. This one contains dy dx because this is not x, this is actually y. So you differentiate it normally, then you multiply also by dy dx. So equal to, now if you look at x and y are two functions here, so we apply the product rule. And I showed the other time in my last video how we could differentiate a product. And I said to differentiate a product, we apply the product rule. So what I will do is, I will differentiate x and keep these two guys without differentiating. Later on, I differentiate y, I keep these two guys without differentiating. So I want to differentiate xy, it will be 6. The differential of x is 1 times y plus 6x. The differential now of y is just dy on dx. So take note of that. The differential of y is dy on dx. The differential of y is dy on dx. So my 3x squared plus 3y squared dy on dx should be equal to 6 times 1 times value is 6y plus 6x dy on dx. Since dy dx is what gives you the gradient of the tangent function, I'm going to take everything that has to do with dy dx on one side, and every term that does not contain dy dx, I take it to the other side. So I will bring this term this other way. So I will bring dy on dx this way, then I will take 3x squared this other way, because the objective is to have a function in terms of dy dx. So I'm going to have 3y squared dy on dx. When this term comes this way, it becomes minus 6x dy on dx should be equal to 6y. This other term goes this way, it becomes negative 3x squared. So from there, you see that dy dx is a common factor. I factor it out. I'll have dy on dx, all that into 3y squared minus 6x should equal to 6y minus 3x squared. So this implies dy on dx should be equal to 6y minus 3x squared, all this divided by 3y squared minus 6x. So my dy on dx, you see that 3 is a common factor, both on the numerator and on the denominator. In the numerator, 3 is a common factor, so I have 3 into 2y minus x squared divided by 3 into y squared minus 2x. So 3 and 3 cancel. So my dy on dx is actually 2y minus x squared on y squared minus 2x. So at point, you say at the point 3, 3. So at 3, 3, you see that x is 3 and my y is 3. So therefore, my dy on dx will actually be, you substitute y as 3 here, you substitute x as 3, substitute y as 3, substitute x as 3. So if you substitute y as 3 here, this will be 2 times 3, which is 6, minus 3 squared, which is 9, on 3 squared, 9, 2 times 3, 6. So that gives me 6 minus 9 is negative 3, or 9 minus 6 is 3. So therefore, my dy on dx is negative 1. This implies the gradient, like I said, the gradient of the tangent is negative 1. But we know that the gradient, okay, so from that relationship, we know that the gradient of the tangent times the gradient of the normal should be equal to negative 1. So this implies substituting the gradient of the tangent as negative 1, negative 1 mn, negative 1 mn should be equal to negative 1. Therefore, my gradient of the normal will just be 1. Since I already have my gradient of the normal, as you can see, the gradient of the normal is obtained from the gradient of the tangent. That's why I said in the beginning of the video that you must first of all understand, or you must first of all obtain the gradient of the tangent, which will permit you to obtain the gradient of the normal. So I will use this relationship now using y minus y1 equal to gradient of normal into x minus x1. What will I have? I'll have y minus my y1, the point is given. So you see that the point is given, y is 3. Y minus 3, the gradient of the normal is 1 into x minus 3. So you see that y minus 3 equal to 1 multiplied by all these x minus 3. So this implies y. If you add 3 on both sides, you add 3 here, you add 3 here, you see that y will be equal to x. So this is the equation of the normal, which is just a line that slopes upward from left to right, passing through the origin. So this normal is a line. This equation is the equation of a line that passes through the origin and sloping upward from left to right. So that is how you can always apply the knowledge of differential calculus in obtaining the normal to a particular curve. So if you are seeing me for the first time, you should share, you should like, you should subscribe to my page so that when I post updates, you can be having the videos immediately. So watch out for my next video. Bye.